Hey everybody, this is Larry. This is me going with Q3 of the recent weekly contest 214, self-diminishing-valued color bars. So this one was, I think, the hardest problem in the contest. Let me do a quick refresh to see how many people solved it. About 200 people solved it about an hour in. Definitely, if you look at the high score, a lot of people took way more time on Q3 than even Q4, and myself included. So definitely a very tricky problem, and we're gonna go over it. And yeah, so this problem, I think there are a couple of things to do. Thing is to understand, right? So the core concept of this problem is greedy. Again, so what does that mean, right? Because as I mentioned, maybe even other videos, greedy means a lot of different things to different people, and there are different ways to be greedy, and sometimes you're right and sometimes you're wrong. In this case, the greedy that I chose to do is that, looking at this example, and for greedy problems, very often you'll see is that in the problems, they especially in the examples, they try to put it in a way that to disguise the greedy method, because otherwise they would just people would just get the answer. So it's something that problem solvers will try to kind of mix it up. So if you, as long as you get the right answer, maybe it doesn't have to be in the same explanation, same way as the explanation. And looking at the example one, I think so for this problem, the amount that you get for a ball is equal to the number of balls already in the inventory. That means that in this case, if you use you buy a ball from the 5 bucket, you get 5, and so forth, and then 4th, and then 3, right? So I think that the greediest way intuitive here is that you always want to take the bucket from the max and then buy from the max, right? Because it doesn't make sense to buy it from a cheaper bucket, because to get the optimal cost. So that's kind of the first observation, and that should be pretty understandable. Or it should be pretty intuitive, though as usual sometimes intuition will throw you awry. But yeah, so then it becomes an implementation problem, right? So the thing that we look at after that is that inventory could be up to 10 to the 9, which is a big number. And also number of orders can be up to 10 to the 9. So that is also definitely a big number. Because basically my first instinct looking at this is, and what we said about greedy is that, okay, if we want to get the max every time, there's a very natural data structure for it, right? Is that we put everything in a heap. And with a heap, we can just take the max element every time and then subtract from it, take one order off the top and then poo, right? And then we could take that order off the top, add it to the total value, and you keep on iterating it orders number of times. However, given that orders is equal to 1 billion, it's going to be too slow, right? You can't run 1 billion heap operation. It's just definitely too slow. And yeah, and even inventory length is 10 to the 5th, so that's going to be pretty rough in general, right? So the thing to notice in this problem, though, is that, okay, right, for a bucket, let's say you want to buy, let's say you have a bucket of 10, or let's even say 100, and you want to buy 10 balls from it, right? Well, the first thing you notice is that, okay, so the first ball is going to be give you $100. Second is going to 99 plus 98 plus 97 plus, right? When does it end? Well, it's going to end at 91 because 10 balls, you could count it out, right? So we have to do the math for this. And it turns out that the math for this is just simply, this is equal to 1 plus 2 plus 3 plus 4 plus plus 91 plus 92 plus 93 plus plus 100, right? Minus 1 plus 2 plus 3 plus 4 plus 5 plus 90. Okay, maybe I should do the 90 here, right? So if you subtract this formula from this formula, you will get this formula, right? And so, and you know that this formula is equal to just 100 times 0101 over 2, and this is just 90 times 91 over 2. So that's basically the math is that, you know, and I should have done it as a helper function. And also my implementation was a little bit weird because in Python, it is a min heap. And I made a couple of mistakes that slowed my submission time down because I had the negative a couple of numbers. And it was very confusing. I need to do a better thing about max heaps in Python because my pattern is just keep on making me focus on stupid mistakes. But anyway, so now, you know, so given a bucket of 100 and we want to buy 10 boards, it is just equal to, yeah, 1 over 2 minus 90 times 91 over 2, right? So that's the one key observation. And then another second key so that's one compression you can do so that you can kind of make it faster, right? Because now you don't have to do this, instead of doing 10 heap operations, you compress to one heap operation, right? But then now the second question is, how do you do, say, let's say 100 and then 95 and you want 10 boards, right? Well, you know that eventually, I mean, we're going to have to massage the math, but that's another case. And let me make this a little bigger, right? But we know that the second state that we want to get to is 95, 95, because at that point, we want to sell the 95s together, right? So this will take with 5 boards left, right? So this is the reduction. Reduces to this problem, 5 boards left, plus, you know, plus equal to buy 5 boards from this, 5 boards left, right? And that's kind of the math that you so those are the two cases, right? The other case might be that, like, you know, 100 and then you have a bucket of 50 and you want 10 boards, but you know, that doesn't matter because you just buy 10 boards and it goes to this, right? So those are your cases. Yeah, and so then now we just have to handle the case of, okay, this case, right? What does that mean? So you just have to, for me, you just have to, you have to do them together. And what I mean by that is that now I will compress this instead of kind of, because, you know, like if you have, I don't know, let's say you have 1 billion and you want to take also 1 billion boards. I don't know if I have the right number of zeros. No, I do actually. So you still cannot simulate this because then this would take 1 billion heap operations, right? So what I do is that I actually compress this to, say, let's just get rid of that. I compress this to a 95 to 2 tuple with 5 boards left so that we can do it together. And then now the math is similar to this thing, and you have to do a lot of case by case analysis, but it's just simple math in that now, well, 5 boards left. That means that we want to buy, there are 2 buckets to buy from. So 5 boards, we want to buy, buy 2 from each bucket first. So that's the reduction. So now it goes to 93.2 with 1 board left. And then now you could just pick one of them because neither of the bucket matters, right? Buy one from either bucket. So that's kind of the logic that I'm trying to implement into my code, and this is the explanation of how I got there. And then now we're gonna go over the code, and of course you have to remember the mod, otherwise you're gonna have a sad day because, yeah. But yeah, so that's how I'm going to think about it, and that's how I implement this. I end up taking a long time, almost 20 minutes, because as I said, I implement stuff with min heap, where I want a max heap. So just carelessness. But yeah, so basically a heap, I start with a heap, I push into the heap, and this is the negative x so that I could get the max heap. But basically I push the x on top with a bucket size of 1. And then while we have orders, while we have heap, we take the top element, we invert it just so that, because we know that this is inverted, and we pop the top, and then we also do this thing to compress. And what I mean by that is that this basically operation goes from, if your heap looks like 95.2, or sorry, 95.1, 95.1, it just compresses to 95.2. So it just compresses the buckets. It gets the next number. This gets the next thing on the top of the list. So that basically, for example, if our case is 95, say 2, and then the next number to care about is 80, we want to, and 5 of them doesn't, or maybe 1 of them, because I guess they all should have only 1. Right, then we take the delta, meaning that after buying 15 times 2 boards from the 95 bucket, we have to look at more items. So that's what the next, on more buckets. So that's what we have to, that's what my next top does here. And then I you know, just, and then all this is just math. I'm gonna go over it briefly, but if you have trouble understanding this part, maybe rewind a little bit, because I do explain it here fully, I hope. So if not, just let me know, ask me questions. But basically, this is the case where orders is way big. So, you know, let's say we have, in this case, let's say we have 100 orders, so we can buy them all, and right. So that's just top to the next top, and again, this is the math, and we have to multiply by the count, because that's the number of count that has that bucket. We subtract it from orders, we add it to the total, we make sure we mod, and that's kind of this logic. Otherwise, then this is the case where I talked about. This is this case right here, where okay, we only have 5 boards left from this, from up 2 buckets of 95. So we do the math. How many orders do we, you know, how many per bucket are we buying from? That's the number. So then we get the fake next top this way, because then we go from 95 to 93, and then we subtract it. Again, this formula we explained earlier, and then we just count, add the number of buckets, and then we multiply by the number of buckets that is in the current bucket, and then we add it to the total. We subtract from the count, and then the leftovers is just, in this case, you have 1 board left, because and this board will always be mod the count, because that's the definition of this part, right? Is whatever's left over from there. I could have used diff mod actually, and then we just kind of look time this by the next top, because we know that leftovers less than count by the definition is modded by count. So basically, we always take the most expensive buckets, and you know, and that's basically the math. And then at the very end, we push it back into the heap, meaning that, for example, we have this case. After we process it, we want to push this to 80 to 2, and then it gets compressed later on by this earlier step. And that's basically it. That's all I have for this problem. It's definitely tricky. It took me 20 minutes. People have gotten it. You know, even really good people took a long time. So I would not feel that bad if you took a while on this one. And there's a lot of potential by off by 1. So it actually, not that many wrong answers on this one, but as I might have expected. But yeah, let me know what you think. And yeah, you could solve it in the. You could watch me approach this problem during the contest next. I have a lot of, like I said, I think my just analyzing myself, things I could have done better, just be more careful about min heap versus max heap. That's a Python thing. And then the second thing is just, I think I spent too much time in the beginning just trying to think if there's another way to do it, instead of like just solving it, even though this way is annoying and hard. I just needed to do it. That's all I have for this one. Yeah, watch me solve it in the contest. Let me know about how you did it. Did you find this problem hard? Was the math okay? Was it, you know, did you have 12 degree? Let me know. I will see you afterwards. Hey, so actually, before I jumped into the solving, I just realized that I forgot to explain the complexity. So yeah, let's go over the complexity real quick. Is that, for each element in the list, we push it to a heap. So that's going to be at least n log n. And n is equals 10 to the fifth. And the question is, how many times do we pop this off? How many iterations does this do, right? Well, that's where we try to figure out an invariant to this problem. And an invariant is that for every iteration, we are always going to get rid of at least one. For every iteration, the heap always shrinks by one element. And the reason why you can see that is that, for every, let's say, you have two elements, for example, that's here. Let me make this bigger. Oops. My computer's a little slow, my apologies. But let's say you have, this is the heap. Well, this heap is going to turn into from 95 to 80. Oops. The next iteration is always going to go to the next number. Right. And the reason why that is the case is because we literally look at the next number to put back in the heap, right? So we're always going to so this is always going to be a function of the next number, and of course we have this thing here that compresses it. So that means that for every iteration, the size of the heap shrinks by 1. So that means that given the heap of initial size n, it's going to take n iterations. And in each of these iterations, there are a couple of log n operations on, actually only, a couple on heap pop and heap push. So there are a couple of log n operations. So it's going to be just n log n is the entire complexity. And in terms of space, we only need the heap for the space. So, and an extra variable. So it's going to be linear time and log n, linear space and log n time, and that's how I would analyze Q3 in terms of complexity. Watch me solve this during the contest next. Thank you for watching and all that stuff. Page 6 for now. So you want to heap it, probably not that much. Oh, is there a mod? This is an annoying one. Let's still use a heap. Okay, fine. Okay. So now what we want to do. That's 10. Going to turn to 8. It'll be 10 and 9. So maybe oops. Now we push it back on top. Oh, this. That's not right. Oh, that may be right. Oh, that's right for this case. It's not right for the other ones. Oh, right. That's not good. Oh, I have to do orders. This is annoying as hell. Oh. This should be 12, so my math is a little bit wrong. Let's fix that first. At least that's more right. Else what do we do? How big can orders be? Can we simulate? Because if this is like 99999, then that'll be just or whatever. Unfortunately, I have a 10-minute penalty, so what a silly. Watched it, gotta slow down, so I'm okay. Just focus on getting it right. So that means that delta times count is less than orders. So for every count, do that first. Top is equal to top minus number. number times count. But then now doesn't. Now there's a orders mod count. So it's just leftover times next top. Yeah. That doesn't make sense that this has more fewer borders. So we have to fix that. This is already wrong. Is 7 words because this is this. Min heaps and max heaps mixes me up. That's not good. Is 0. This is what's going to happen. Oh, oof. Yeah, more right answers. It's still wrong on this one. I think right on this one though. Wrong on this one. Why? Probably off by 1. Let's see. It's good. Five 129 is 504. 22, so it should be. This math is wrong. So orders. That's good. I need this number. So So you did 2 4 numbers as left. That's good. Number is 2. We do want 2 iteration of this. So that means that we next top should be 1. Right? So why is the delta now so high? 5. Because it should be 3 times 3 is 6. Oh. Is that right? No, this is count. 19, alright. I mean, this is way bad for the test examples. I'm not confident about this one. Okay. Thanks for watching, everybody. Remember to hit the like button, hit the subscribe button, join me on Discord, and we'll chat about stuff later. Bye-bye.